app here. I've got a little car. This is kind of like what I was doing on the floor there. If I put go, the car drives, turns. I've never seen a car turn quite like that, but you get the idea. Okay, so how many exterior angles did it turn through? 5. And if I put show measurements, there's the 5, and if we add those up, we better get what? 360. So here's this slider, and he just comes through and it measures the angle. And what's fun is you can actually take this and change this pentagon to be different than the one that was there. Notice the angles change, but our total should still be the same. What is the total angles turned by the car? And so on. Okay. I thought I'd made that available to you. I'll throw it out there for you to be able to look through it. Oh, by the way, if you look at any polygon, an exterior angle, for example, if we go to this vertex here, by extending this side, okay, this right here is an exterior angle, right? But if I extended this side, then this is also an exterior angle. So technically there are 2 exterior angles that can be made at each vertex. And when we say the total is 360, we are saying that that is counting 1 exterior angle per vertex. If we counted both of them, it would be 720. Right, twice that.
Does it matter which one you count, or do you have to count the same line going each direction?
What do you think?
Nope, it won't matter which one.
Why won't it matter?
Because they share a common angle. The center, the interior angle is the same. Doesn't matter which way you go. It's the same.
These
value.
2 exterior angles are the very same size. How do we know? They're vertical. It's a pair of vertical angles. And we've decided that vertical angles are congruent. So I could use one on one vertex and another one on, as long as I just used one per vertex.
Okay.
Okay, good question. All right. Let's hear your questions from, is there anybody that after they discuss, they're still not quite sure of one or more of the characteristics? Yes?
The line of symmetry.
For?
Well, the last 3, they don't have exactly 1. So when I looked it up on GeoGebra, I just clicked, checked the box for the line of symmetry, and it only showed 1, so I just assumed it was only 1. But it says there's more to the side.
For which?
I guess
For
we
which
don't
of-
know how to use the GeoGebra tool.
Okay.
We'll find this.
So
What does symmetry mean?
you can flip it.
I saw this flip so that you could actually take the quadrilateral and fold it along that line, and what would happen? It would match up. If we had patty paper and we had it drawn on the patty paper and we folded it along the line of symmetry and held it up, the lines would be right on top of each other, right? Okay, it's kind of like our body. We're going to get into this a little bit more. Bilateral symmetry in Unit 3. If we were to draw a line right down the center and hold one half of our body onto the other, it would match, right? Except for those of us who part our hair down one side or the other, and then that wouldn't quite, you have to part your hair right down the middle for it to work, right? Plus there are people that have a mole or a beauty mark, somewhere here that may not be on the other side exactly. And I have a brother who one of his ears is actually bigger than the other. And you don't notice it until he tells you, and then, oh yeah, you're right. Anyway, so they're not exactly symmetrical, but so what we tried to do with the app was give you an idea of what symmetry was. Whether you can get all of the symmetry lines from the app, that I don't know. So which of the quadrilaterals are you most?
We can just do a rhombus and circle.
Okay, a rhombus. By the way, what's the definition of a rhombus? We're going to... Yeah.
I was just going to say, with regards to the app, when you click the checkbox that says "Show me the lines of symmetry," that'll only show you potential lines of where it might be, but it'll pop up a second box underneath it. And when you click that one for check symmetry, it'll actually create a mirror image, and it'll flip it across that line. You can rotate the line around so you can see.
You can see if there's more. Oh, okay. I just saw that, but I didn't know what it meant.
So to see if there are more, you
Move the potential line of symmetry around.
grab the potential line of symmetry and move it and watch what happens. And if you can get it in another spot, then there's where it matches. Okay? All right. Some of you have never ever used this software before, and you're getting used to it. Question, comment?
I don't know what it's doing.
Definition for a rhombus. Who wants to give me one? Yes.
Parallelogram where all the sides are the same.
A.
Parallelogram.
So
Or
could we say it?
quadrilateral where both sides are
An
parallel.
equilateral parallelogram. Is that a definition for a rhombus? Anybody have a different one? Trying to do it in as compact as we can. That without the "and," it's two words, right? It's a parallelogram and equilateral. Everybody know what this means? Lateral means side, equal side. Okay? So that's the same length as that, which is the same length as that, which is the same length as that. And where can I put a line of symmetry? Here? Is that it? There? The top would fold to the bottom, or the bottom up, the left to the right, or right to the left. Two? Okay, any others?
They have the same opposite angles. Like the top one and the bottom one would be the same.
This angle is the same as that one?
Yeah.
And
then that's the same as
this
the other
one's the
one.
same as this one? Okay. Is that true of any parallelogram or just equilateral parallelograms?
Just equilateral.
What if I had one that was
It's still the same angle.
Is this
so-
one the same as that one?
Yeah.
And this one the same as that one? So opposite angles are is true for not just rhombuses, but parallelograms?
Yeah, and the reason is because they're vertical or parallel. Sorry, parallel. And so when they're parallel,
If the lines are parallel,
they're parallel.
yeah, here I've got two parallel lines, right?
That's because both sets are parallel.
Both sets are parallel. Okay. Did we answer your question, or is there more of those symmetry ones you? Anybody else came across any that you were wondering about? Yes.
I just have a question to make sure I understand. When diagonals bisect each other, they cross each other, but also the opposite sides, do they have to be equal?
When we say bisect,
Or the
that's
opposite
different than
triangles.
intersect.
Okay.
I know,
So-
there's confused.
If I draw in a diagonal here and a diagonal here, bisect means this diagonal cuts this one in half, so this length's the same as that. And this diagonal cuts that one in half, so this side's the same as that. This distance is the same as that. That's what bisect means.
So if the distances are the same, then
Then they don't bisect each other. Okay? If each side's not the same length, it has not been bisected.
Well, since it's two parallel lines and two sets of parallel lines and they're just transversals of each other, shouldn't all those diagonals be equal distance themselves? Like, they're both bisecting each other for this example?
I think we could say that this angle here and this angle here is because alternate interior angles, but the lengths of the
lines?
the diagonals. You're saying the fact that they're parallel?
Well, both sets of parallel, they're just transversals of each other. And they're bisecting the angles with each other that technically shouldn't those also be the same length?
Okay, so here I've got,
Not for all examples, that example.
here we've got two diagonals. Do they bisect each other? Obviously not, because this length is not the same as that. So in order for that to happen, we have to have two pair of parallel. What you're saying?
Well, two parallel, but the parallel lines have to be equal distance, equal length.
Equal length.
Mm-hmm.
Okay.
On both sets have to be parallel, like the
Okay.
vertical and then horizontal ones. Then that would be the same distance across for when they bisect each other.
Okay. How would we define a square? This here is for a rhombus. How would you define square? Anybody?
Rhombus and vertex, since they're all the same angle.
90-degree angles.
A rhombus whose angles
They're
are
all the same.
all the same, which makes it a equiangular rhombus. Will that do it? Could you draw an equiangular rhombus that wasn't a square? Can you draw an equiangular rhombus and have it turn out to not be a square? Okay. Anybody have another definition for square? Yeah.
Could you say like equilateral rectangle?
Let's check it out. Can you draw a rectangle that's equilateral that isn't a square? So these two definitions don't look anything alike, right? And yet either one of them is sufficient to give us the definition. What's the definition of a trapezoid? Yeah.
I'm trying to think of like a two-word one, but like a quadrilateral with one set of parallel lines.
Quadrilateral with one pair. You're talking exactly one? I'm going to put that in. Exactly one pair of parallel lines. That is actually the definition that is used in most of the textbooks that you will be teaching out of. However, I think it's interesting to note that mathematicians do not agree completely on the definition of a trapezoid. Some of them say it's this, and others say it's this. So I'm going to put definition 1 and definition 2. Sides, I guess. That's a different definition, right? Under that definition, talk to me. What would, yeah.
Couldn't a parallelogram be a trapezoid?
A parallelogram
Like the
would
same thing as a
would
square.
be a trapezoid under this definition, right? Because it has at least one pair parallel. It has two pair. A square would be a trapezoid under this definition because a square has at least one pair of parallel sides. And there's some reasons why they define it that way, and I don't want to get into that right now. I want you to be thinking about that, but let's see. Let's continue this over here. What I'd like to do is, I would like to review something that I think you've all seen before. I know they were used in Math 108 and probably before you even got to BYU Idaho, and that's a Venn diagram. Venn diagrams are extremely useful, not just in mathematics. Let me just illustrate a non-mathematical one. How many elementary teachers in here? Most of you. You can use Venn diagrams for all kinds of subjects. I'm going to pick science, and I'm going to label this set the chordates. Chordata. What does that mean? Anybody remember that from your... Spinal cord, yeah. It's animals with a spinal cord. Okay? So, over here I could put fish, right? What else could I put in here?
Monkeys.
Monkeys. Okay. Should I put it inside of this one? Should I put it overlapping with this one, or should I put it completely outside of that one?
Outside of that.
So monkeys go here, right?
You can put monkeys inside of primates, and you can put primates inside of mammals.
Okay, so this is primates.
Yes and no.
And mammals is this one here, right? We say that primates is a, of mammals, what? Subset, right? A subset. That's because you cannot find a primate that is not a mammal, right? What about birds? Where would they go? Are they even in here? Do I put them out here? Are they mammals?
Warm-blooded, but they don't have hair.
Warm-blooded, but they don't have hair, so they lay eggs. So where do I put it?
Fish.
In the fish? Overlapping with the fish?
It depends on what type of category we want, because if we want things that lay eggs, they would intersect with fish.
What about frog?
It lays eggs. And so it all depends on what we want to compare.
Depends on how we define our... Okay. What would you say if I said birds went like this?
Well, what are you defining as the inside thing?
Well, what could I put here? Flamingos? Is the flamingo considered a mammal?
No.
We know it's a bird, but
Maybe what they eat.
I'm just like, would you, a bat's not a bird,
a bat is not a bird.
but it's a mammal.
It's a mammal. So if we had a category of a set that flies, you could say we could overlap them, but nobody thinks I can overlap birds with mammals?
Can a platypus ever be considered a bird?
Whoa. Let's try putting a platypus. Is it Y? Platypus. Why might it go there?
Well, it has a beak.
Has a beak.
It lays eggs.
It lays eggs. But
A characteristic
it's
of
warm. It's warm-blooded as both, but it
doesn't have live birth, which is a category. of
doesn't
mammal.
have live birth, but it suckles its young with milk. It has mammary glands.
And it has
And
hair,
that
fur.
is really only mammals have that, right? Can everybody see how the platypus might be in both categories? All right. So what I want you to do is, I want you to plot a piece of paper. We're going to call this polygons. What is a polygon? Polygon is when you left the door open to your parrot's cage. Just kidding. Okay.
That's a me
Poly means what? Many. So this is a many-sided. Inside here, we're going to have one called quadrilaterals. That means it's got what? 4 sides. So out here would be a pentagon and a hexagon and an octagon, but we're not going to worry about outside of here. What I'd like you to do, I want polygons, quadrilaterals, and then I'd like you to put every one of the those quadrilaterals we gave you into a set. And if they're complete subsets, they've got to be completely inside, like monkey is completely inside here. But if there are common things between them, you should have overlap. And what I'd like you to do is use this definition right here for trapezoid. Use this definition for trapezoid. Okay? And after you've got every one of those every one of the quadrilaterals down, and what do I mean by every one? Well, what I mean by every one is you should have kite, trapezoid, isosceles trapezoid, parallelogram, rhombus, rectangle, and square. The ones that we had there. They should all be in your diagram somewhere. Okay? And once you have yours completed and you think it's right, share it with a neighbor. Okay? Share with a neighbor.
Definition 2, we're okay with the trapezoid. But you said to go by definition 1, right?
Right.
So since they only have one set of parallel sides, rectangles and squares can't be trapezoids because they have a second set.
So you're saying that
The
what shouldn't be where?
The parallelograms, all of that should not be in the trapezoids.
What do you think?
If we were going
You
by the
shouldn't.
second,
You think it shouldn't?
Yeah, it shouldn't be in there because parallelograms, both of the sides are gonna be parallel, but in a trapezoid.
Do you have to make a big change on our diagram, or could you just go make a small change and have it do what?
It wouldn't be a pretty circle, but we can fix it.
Well, they don't have to be pretty circles, they just have to be accurate.
If we're going by definition 2, this would be right. But if you just... Yeah. Do like that. And then, I'm curious about kites, because technically can't a square be a kite?
Yes?
Yeah.
No?
Yeah, I have no idea where kite went.
I don't know. I was just trying to figure it out, because I was like...
It depends on how we define a kite, right? So, for Thursday, see if you can come up with an accurate definition of kite.